Greetings and welcome to this video lectures on natural language processing. This is Dr. R.Usharani, Assistant Professor, Department of Computational Intelligence, SRM Institute of Science and Technology, KATANGALATHUR. The purpose of this video lectures is to explore the fundamentals of natural language processing, its challenges, key concepts, applications and its application areas, and NLP development tools. To achieve this purpose, let us look at the learning objective of this session. By this end of this session, we will be able to understand the basics of natural language processing, identify common challenges in NLP, understand tokenization as the first step in NLP text processing. After understanding the tokenization, we can understand word embeddings, how word embeddings represents words in a meaningful way. Next, recognize lexical semantic relationship between words. After that, explore NLP application and application areas. Finally, NLP tools and libraries for NLP development. Let us begin with the fundamentals of NLP. First, what NLP is. We need to understand this. Natural language processing is a branch of artificial intelligence that enables computers to understand, process, and generate human language, making communication between human and computers more effective way and a natural way. The importance of natural language processing are: it enables computers to read, understand, and generate text or speech. It combines language knowledge with artificial intelligence techniques to make communication between humans and computers easier and effective way. With NLP, people can interact with computers using natural languages such as English, Tamil, Hindi, or any other languages are also possible. Many everyday applications such as chatbots, translation systems, and voice assistants are powered by NLP. After understood the basics of NLP, let us examine key challenges in NLP. A major key challenges in NLP is ambiguity. It is nothing but confusion where it occurs, where the same sentence may have multiple meanings. Context is required to determine the intended interpretation. Human can understand the context and sentences and that situation around all this easily. But on the other hand, computer, it requires to understand and determine the intended interpretation. Let us consider some examples to understand this. Consider the first example sentence: I called my friend from the library. It may have many interpretations. Let us consider interpretation 1. I was in the library when I made the call. Second interpretation, my friend is from the library. Here the ambiguity is, what does from the library connect to? The action called or the noun friend. Similarly, we can consider as second sentence example. My daughter Darshika photographed the bird near the lake. Then we can consider two interpretations here. First interpretation, she took the photograph while standing near the lake. Second interpretation, the bird was near the lake. The ambiguity is, what does near the lake connect to? The action photographed or the noun bird? So, the NLP systems must determine which interpretation is most likely by using the sentence structure and surrounding context. This makes ambiguity one of the fundamental challenges in natural language processing. After understood, then we need to understand the type of ambiguities. There are several types. Major categories are structural ambiguity, grammatical ambiguity, and lexical ambiguity. Some of the examples we will learn for all these types. Let us consider structural ambiguities with two examples. First example is Namrata thinks she understands me. The possible interpretations: she may refer to Namrata or another female person. Another example we can consider here: visiting relatives can be a nuisance. In this sentence, the possible interpretations: relatives who are visiting can be a nuisance, or visiting relatives can be a nuisance. Similarly, we can consider another type of ambiguity, grammatical ambiguity. There are two examples given here. I go. In many languages, the subject may not indicate whether the speaker is male or female. Another example, the word can. Can may be a noun, like a container, water can, like that. A modal verb, can swim, can play, isn't it? So these two, I go and can, under the categories grammatical ambiguity examples. Similarly, we can consider other examples for lexical ambiguity. Lexical ambiguity, let us consider polysemy, homonymy, several types are there. We will learn in our next slides. First, we understand what is lexical ambiguity using these examples. The word understand. It may have multiple related meanings depending on context. Lexical ambiguity, another example is bank. Bank may refer to a financial institution or side of a river. So these are all the examples for these three major categories of ambiguities, such as structural, grammatical, and lexical ambiguities. After that, after understanding all these things, how computers read, the first step in NLP is tokenization. It's nothing but breaking a text into a smaller units called tokens. Tokens can be words, numbers, punctuation marks, or special symbols. Let us consider an example. Hello, my dears. NLP is exciting and amazing, isn't it? We can consider this example with the tokenization, which means breaking a text into smaller units. So the text contains the word hello, comma, and the next word my, next word dears, and the exclamation mark, next the word NLP. Similarly, all others word extract are separate as a smaller units here. There are 14 tokens available in this sentence. This is otherwise known as tokenization. After tokenization, the computers convert each token into a list of numbers called an embedding or vector, which is known as word embeddings. The word embeddings are learned using neural networks, which repeatedly predict word context and improve their vector representations through the statistical functions such as loss calculation, backpropagation, and gradient descent, etc. To achieve this, techniques such as word-to-vector, that is word-to-vec, and glove are commonly used. Several other techniques are also available. Later we will discuss. These vectors help computers understand the meaning of words and identify relationship between them. In word embeddings, let us consider step 1, convert words into vectors. That is otherwise known as embedding. Let us consider the table. Here some of the words considered from our previous sentence. Hello, NLP, exciting, amazing. These are all the words taking from our previous example sentence. Here, the word embedding numbers, that is vectors represented here is 0.12, 0.45, etc. something like that. What are all they? Randomly, the computer generated these numbers for the word hello. This is not an accurate numbers. Let us consider for word embedding example. So the computers generated some vectors or numerical values for the word hello. Equally, it has some patterns. These numbers represented by some patterns. Similarly, another word NLP, it has also some vectors or numerical values and patterns. And the word exciting with embedding or vector values with patterns. Next word amazing with vector values and patterns. Let us consider the word exciting and amazing. The vector numbers closely related to one another. 0.85, 0.91 represented exciting. 0.83, 0.88 represented amazing. So the values are closely related to each other, means there is some meaning closely related to these two words. On the other hand, consider the word hello and NLP. There is difference between these two values. Hello represented by 0.12, the starting vector. On the other hand, NLP, the word NLP 0.78. There is much difference between them. So from this context, we can understand if any two words closely related to same meaning, then the vector numbers and then patterns closely related to each other. And the next step, it can use to measure the similarity between words. Let us consider the previous example here, exciting and amazing. Then the vectors and patterns are closely related to each other. Therefore, the similarity, let us assume 95% of similarity between these two words. Because from the observation, exciting and amazing have a higher similarity score because they express similar positive meanings. Next, words, NLP and exciting, 72% of similarity score. NLP is somewhat related to exciting in given context. Next, we can take the words hello and NLP. 21% only, because hello has a lower similarity with the other words because it is primarily a greeting. Hello, amazing also. So word embeddings represent words as numerical vectors, enabling computers to measure semantic similarity between words. After understood that word embeddings, we can move on lexical relationship between words, that is otherwise known as lexical semantic relations. This is otherwise known as transition sentence from embeddings. The word embeddings help computers represent words as vectors and measure similarity. Beyond similarity, NLP also studies various semantic relationship between words, which is known as lexical semantic relations. Let us consider and look at this table. Some word similarity example and the semantic similarity example given here. Consider the first example, mother and other. Words have similar pronunciation and spelling, but different meanings. Next example, words mother and mom. Here words have similar meanings even though the forms differ. So We can understand from this lexical semantic relations in NLP, the standard NLP linguistic term covering several types: synonymy, antonymy, polysemy, homonymy, hypernymy, hyponymy, meronymy, and holonymy. We will see some examples for all these types. Look at the table. The relationship types are given here: synonymy, antonymy, etc. First, we will look at synonymy. Example is mother and mom. Same meaning. Here, different words with the same or nearly the same meaning. Antonymy example: happy with the word sad. This gives us a meaning, opposite meaning. Words have opposite meanings. That is otherwise known as antonymy. Polysemy means, let us consider some example. Head, the word head. It may denote person's head or department head. That is any person's head. Otherwise, head of the department. Here, a single word can have more than one related meanings. That is called polysemy. Next, we can consider homonymy example. Consider the word bat. The word may represent as animal. Otherwise, sports equipment also possible. Here, multiple unrelated meanings. Polysemy can have more than one related meanings. On the other hand, homonymy, a single word can have more than one unrelated meaning. Sports equipment unrelated with the animal. So that may represent animal, otherwise sports equipment. Based on the context, we need to consider what it is. Next one, hypernymy. Take the example, words for animal and dog. That is general to specific. A hypernymy is a broader category that includes more specific terms. Hyponymy, on the other hand, this is the reverse case of hypernymy. Specific to general. General to specific represented by hypernymy. General to specific is hypernymy. Specific to general, hyponymy. Next one, meronymy. Wheel and car. Car is a whole relation. Relation means nothing but in our DBMS concept, relation represented as a table. Similarly, that is an entity. Whole relation. Car is a whole relation. Wheel is a part of that relation. So a meronymy represents a part of larger object with its parts. And holonymy, the reverse case of meronymy. We can consider the same example reversely. Car with wheel. Then car whole part, wheel is a relation, part of the relation. So these are all the standard NLP or linguistics. Hope you all understood all these standard NLP linguistics types with examples. Next, we move on NLP application landscape. So the NLP used to build many real-world applications. The picture represented NLP topics are connected and contribute to various language processing tasks. Chatbots, email filtering, language translation, sentiment analysis, predictive text whenever typing text or sentences in our Google search engine or mobile, it predicts the next words, that is predictive text. Text summarization. In a large amount of document or PDF, we can summarize as a small paragraph as possible. And smart assistant, Alexa, like that. AES, automated essay scoring, automatically score the essay based on some criterion. These are all the applications of natural language processing examples. Next, we move on some NLP application areas. That is, application area, we consider text to speech and speech recognition. Example is voice assistant and speech to text. Next, consider the healthcare sector. Clinical notes analysis is an example. Disease monitoring is another example. We can book an appointment with specific doctor through chatbot. These are all the healthcare sector examples. Next application area, natural language interfaces to databases. Here, we are querying databases using natural language processing are possible. And information retrieval. Using search engine, we can retrieve informations in the easiest way. And information extraction, named entity recognition is the example for information extraction. Next, document classification, spam detection, topic classification. These are all the examples for document classification. Document image analysis. Optical character read from scanned documents is the best example for document image analysis. Automatic summarization, summarizing large articles into smaller one. That is automatic summarization. Text proofreading, spelling and grammar checking, Grammarly, like that tool. Ginger, these are all the example tools for text proofreading, spelling and grammar checking. Next, machine translation. We can translate some language to some other language, English to Tamil, English to French. Similarly, many language translations are possible. Next, fact news and cyberbullying detection. Example, social media monitoring. If we consider social media monitoring, then trend and opinion analysis also possible. And plagiarism detection, similarity checking in documents. And look ahead typing or word prediction, mobile keyboard suggestions. Nowadays we are typing any information, next text suggested automatically by this NLP. And question answering systems, ChatGPT, frequently asked question systems. These are all the examples for question answering systems. And sentimental analysis, positive, negative, neutral opinion detection. These categories under the sentimental analysis, we can take it as an example. So these are all the some of the NLP application areas with examples. Next, we move on NLP tools. Commercial tools and open source tools are available. Some of the commercial tools are tabulated here. IBM Watson, AI platform for business applications is IBM Watson. And cloud, Google Cloud NLP API. This is Google's cloud-based NLP service. And Amazon Comprehend, that is AWS service for text analysis and insights provided here. Similarly, we look at this open source tools also, which is also tabulated here. Stanford Core NLP. This is Java-based NLP toolkit development by Stanford University. And Sparsy, fast and modern Python library for natural language processing. GenSim, another tool, library for topic modeling and document similarity analysis. And natural language toolkit, NLTK. This is popular Python toolkit for NLP education purpose and research work purpose. This is used for these purposes. and GPT, that is generative language model used for text generation and prediction, and Allen NLP, deep learning framework for NLP research and prototyping, and Berkeley neural parser, high accuracy parser for syntactic analysis of sentences. These are all the NLP open source tools for your reference. So after understanding all these things, we can summarize all these concepts as a key takeaways. NLP enables computers to understand and process human language. Here, ambiguity is one of the major challenges in NLP. Next, hope you all understood tokenization. What is tokenization? It is the first step of the NLP text processing. It breaks text into smaller units called tokens. After tokenization, we can do the word embeddings. It represents word as numerical vectors and help measure the similarity levels between the words. Next is lexical semantic relationship between words. It describes relationship between words and meanings also. After that, NLP powers many real-world applications such as translation, chatbot, sentiment analysis, and text summarization. We have seen already. And also we have seen various NLP tools and libraries help developers build intelligent language processing systems. Thank you.